Okay, so hi everyone, Senan this side, and in this video we are going to see how to solve this minimum time difference, right? This is a great problem and it's not that difficult as well. So you are given a list of 24-hour clock time points in HH and mm, that is hours and minutes format. Return the minimum minutes difference between any two time points in the list. So for example, if you see, that's 11:59 p.m. and that's 12 a.m., right? So just after 1 minute this time would be this, right? 12 a.m. So the difference is actually 1 minute. So we have to return the answer in number of minutes, right? For example, if this is the list, so you could see this that 00 and 00 are same, so that means your output is exactly 0. So you need to find two numbers from this list and find the minimum time difference between them. So I'll show you two methods. One is more or less like a brute force approach, but that still is accepted, right? So given the constraints, you see 2 into 10 to the power 4 could actually go around by using an n square algorithm, right? Although we are going to optimize that n square, but just see this, we are able to solve this in n square, although the time complexity is not that great in that case, but it's possible. In any other problem this would give you a time limit exceeded, but in this it's not the case. So a couple of things you should note, that this number is actually greater than this, but still the difference is 1, right? So we are in a way trying to take the difference of circular elements, like because a clock is in a circle, right? So after 11:59 it's 12, so we have to keep track of that as well. So that's some idea. I'll go over the solution. Before that I'll show you the idea, the logic, and after that it would be very easier for you itself to solve this problem. So very first thing we would need is, how do we actually compare the two times, right? Like this and this, how do we actually do the comparison? So let's look at my notebook, what I have there. Okay, so we have two random time points that I've taken. So what I'll do is, first, to actually do a comparison, how many minutes do you have in a day? So minutes so there are 24 hours and every hour has 60 minutes. This is the amount of minutes in a day. So minutes in 12 hours is exactly the half of this value, which is 12 into 60. We are not actually going to solve this value. We let the computer handle that computation, but that is the idea. So let's try to first convert this. So you'll be given this as a string, right? So first we have to do is to convert this to an integer so that our comparison is easier. So first of all, what I'll do is I'll take this 23 is denoting hours, right? So 23, and I'll take this 59 and I'll add 59 to it. So this is minutes, this is hours. So I need to convert this hours into minutes first. So that means I'll multiply this by 60, and that is how you would actually get the value in integer. In this case you have 11 times 60 plus 40. Now doing this ensures that every time in the day has a unique integer representation and which can be actually compared. So this value is greater than this, right? So that means after 11:47 only you can actually achieve 23:59, right? Although the difference would be more than 12 hours, but the idea is this. So let's take any other example. So 6 a.m. So this would be 6 into 60 plus 0, or I'll take 15:30, that is 3:30 p.m. So 15 into 60 plus, so every time in the day has a unique integer representation which can actually be compared. So now I'll go with the code first of this conversion, then we'll talk after what to do. Okay, so I've written two private function, which is character to digit. So since I'm using C++, so what I do is I take a digit as an input, and what I do is I take that digit minus this 0. So this is actually doing the ASCII conversion, and it would actually give me the digit in integer which is stored in this character. Now this is hours and minutes. So if you see, observe, you have HH, right? So this is 0th index, this is first index, this is third index, and this is fourth index, right? And this colon is actually the second index. So you see this, this times this digit times 10 plus this digit would actually give you the integer number for this HH. Similarly, for this mm, you do this 10 times the first m, and plus the second m would give you actually the minutes. So now what you do is you do 60 times hours plus minutes, and would return you a number. Fine. Okay, so that is one thing. And now most important thing, you have to observe that we got 23:59, right? And to go to 00:00 12 a.m. we only had 1 minute. So if you look at a clock, we are actually trying to find this absolute difference of this two lengths, right? Okay, so how do we actually go about solving? So first of all, you have to observe difference between any two time points. Any two time points is less than equal to 12 hours. You really have to observe this. It's not 24 hours, it's 12 hours. So because if you take any two time, right, let's say if you take any time on the clock, and let's say this is for 12 a.m. or 12 p.m. and this is 8 p.m. or let's say 12 a.m., right? So that means it's for 12 a.m. and let's say we have to find the difference between 8 p.m., which is what, 20:00, right? So we need to find the difference between these two. Difference between these two is not 20 if I just subtract, or maybe this value is 20 into 60. That's not the case. What I'll do is okay, before doing anything, just observe the actual difference between these two is 4 hours. It's not 20 hours, it's 4 hours, right? Difference between any two is actually less than equal to 12 hours. And let's look at another test case. Let's say 0, 0 and 18. Difference is not 18 hours, difference is actually 6 hours. So you need to go to the closest, the next days, right? So to handle this case, what I'll do is, if the difference is greater than 12 hours, what I'll do is I'll take this difference and I'll reassign this to 24 hours minus this difference. So difference is less than greater than 12 hours, difference would again come back within the range of, let's say, 12 hours. So that is the idea. You have to have a feel about this, why this is true. So the next is, how do you actually do the comparison? So what I'll do is I'll take all the time and create a list of all the numbers a, b, c, d, dot dot dot, and whatever last element is. I would convert all of this input time to an integer, everyone, and I'll use two for loops and try to find difference between them and store the minimum value. Now let's actually look at the code. So I'll get the number of n as the time points. Minimum difference is int max. You could take any other number which is greater than this total time, or you could actually take 12 hours as well. So half time is equal to total time by 2. So first of all, what I do is I convert this time points from string to an integer and store that into a vector of list of int. Now what I do is I take the time difference of every pair of elements and I say time difference is absolute of minutes of I minus minutes of j. Now if time difference is greater than half time, so what I'll do is I'll take total time minus time difference, which will give me the new time difference. Clear? Would give me, this code would always give me the difference within 12 hours. Now what I do is I take the minimum difference is minimum of minimum difference and time difference. So if I found a new minimum element, I'll just reassign that to minimum difference, and in the end I would return the minimum. This was one of the way. This actually only beats 5%, not 95%. So that was the brute force approach. Now to optimize this, what you could actually do is you could have the same code till here, till getting the solution, and what you could do is you could actually just sort those elements, right, based on the time, and you could actually take the difference of adjacent elements, and if the time difference is greater than half time, you do the same thing. So this part is exactly the same, right? The only difference is you would see is here. Why am I doing this? The only reason I'm doing this because from the n minus 1th element I also have to compare the 0th element, right? So when I do the sorting, this number would be at the end and this number would be at the start. So after doing the comparison, I need to take the other way around as well. So I need to compare the last element with the first element. So we are actually going in a cycle. So there are n elements and we have to do actually n comparisons. So that is why I plus 1 modulo n. So this would always traverse in a circular fashion, and otherwise the code is same. And if you see, we are only able to do this in a single for loop, right? So yep, and this one actually gives us the 95.56% runtime, and that's quite good. So let's discuss the time and space complexity of this problem, which is, for this problem, I stored big of n for storing the minutes, right? Or in this case, what you could actually do is, rather than storing these elements, you could just actually call this convert to minutes function at this point of time itself, rather than storing it somewhere. You can actually do it within this, so you won't have to do extra space complexity. So you could omit that if you want to, but for the sake of doing this, big O of n is space complexity, and this is big O of n square time complexity, because we are trying to find all pairs, right? And that would take n times n, so n square. And yep, that's one thing. For the optimized version, what I'm doing is I'm just doing everything as this. Here also we are using, what do I say, big of n space, and sorting also takes big of n space. And but the time complexity in this case would be, it's not big of n because of this for loop, it's n log n because of this sort function. So n log n plus big O of n, so n log n dominates. So the time complexity for this one is actually n log n, which is the best you could actually get in this problem. So we saw a brute force approach and an optimized version as well. The space complexity in both cases big O of n, time is n square in the brute force, and big O of n log n for the sorting one. So yep, that was the whole video. Hope I was able to explain this to you, and I'll see you in the next video.